Good afternoon. Myself Totan, Assistant Professor of Chemistry. So today I want to discuss about the nucleophilic substitution reaction. So basically the SN1 and SN2 reaction. So first of all we know what is the nucleophile. So nucleophile are the electron rich species. So they can react the electrophilic centers. They may be negative charge or neutral species. So here the nucleophile attack on the general reaction. So this is the alkyl halide, then HO minus, this is the negative nucleophile which is attack this alkyl group. Then we can get the HOR and X is the leaving group. So this is the general example of a nucleophilic substitution reaction. So to be good leaving group, the substituent must be able to live as a relatively stable and weakly basic molecule or ion. In alkyl halide, the leaving group is the halogen substitute. It lives as a halide as a ions. So nucleophilic substitution reaction, first of all discuss the SN2 reaction. So SN2 stands for the bimolecular nucleophilic substitution. The rate of the reaction depends on the concentration of the alkyl halide and the nucleophile, and the reaction is the second order overall. The reaction first order with respect to the substrate, and if we consider the nucleophile, this is the second order. And we getting from the rate equation. So rate is proportional to the substrate concentration and the nucleophilic concentration. So this is the second order. The mechanism for the SN2 reaction, the nucleophile attack from the back side and the leaving group from bearing the leaving group from the back side. The bond between the nucleophile and the carbon atom formed, and the bond between the carbon atom and the leaving group is varying. The configuration of the carbon atom due to the attack of the backside attack, so we can the inverted product during the SN2 reaction. So this is the reaction scheme. So mechanistic scheme. So here the nucleophile attack from the backside carbon atom and shell group is removed. So this is the single step reaction. So this is the transition state. So negative charge and attack this carbon and shell is removed. This is simultaneously occur. So we can get the inverted product. This is a general mechanism for the SN2 reaction. So this is the free energy diagram. So initially the free energy coordinate, and this is the reaction coordinate. This is the reactant energy, and this is the transition state, and this is the product. So this is for the exothermic graph. So from this is the stable compound we obtain due to the less energy. And this also the similar types of SN2 graph for the methanol substrate only. Then the stereochemistry, this is the most important point here. So the nucleophile due to the attack from the backside, so inverted product, inversion of configuration. So if it is R, so we can get the S. Or if we starting material S configuration, then we can get the R. This is the main motto of our SN2 stereochemistry. So we can get which group with the importance leaving group, fluorine, chlorine, bromine, iodine, and from the bond dissociation energy we can predict that these are the good leaving group. I minus, we consider the I minus is the best leaving group, then the F minus due to the large size and larger polarizing power. So we write in some important point, the nature of the substrate and that the power of the nucleophile, the ability of leaving group to leave, and the nature of the solvent. These are the key factors to determine our the SN2 reactions. So substrate, if the substrate is a very less sterically hindered, so backside attack is very easy. So for this reason, the methyl chloride and tersolic chloride, among them the methyl chloride is the more favorable for the SN2 attack. The powerful and nucleophile, if we attack the H2O and OH minus, both are the nucleophile, but OH minus is the much more nucleophilic character than the H2. So if we carried out the reaction in the presence of the OH minus, instead of the H2O, so we can get the good result in the case of OH minus. So nucleophile act as a play an important role for our SN2 reaction. The ability of the leaving group, so we already discussed the I minus the more leaving nature, so I minus is give the good result. And the nature of the solvent, in the solvent play a important role, solvent play because the nucleophile is attacked. So here nucleophile is attack the this is hydrogen nucleophile. If a polar protic solvent is used, so there is a hydrogen bonding, so nucleophilicity is reduces. For this reason, the polar aprotic solvent just like THF, DMSO, DMF, such type of solvent are the very important for our SN2 reaction. And some example of the SN2 reaction, this is the inhibit our SN2 reaction. In this case, the double bonded compound is there, vinyl bromide, benzyl. So here the lone pair of bromine is participate to the resonance due to the conjugation is involved. So this CBr bond is partially converted to the double bonded character. For this reason, these are the very interactive in our SN2 reaction. This is nucleophilicity order, which is a good nucleophile. These are the main effect of the solvent. Yes. So we have already covered the SN2 reaction. Then we discuss the SN1 reaction. In SN1 reaction is the unimolecular nucleophilic substitution reaction. The reaction is occurs as a two-step reaction, positive two-step reaction. In the first step is the formation of carbocation, and this is the slowest step, and the rate of the SN1 reaction is depend upon the carbocation stability. And the second step, the nucleophile attack to the carbocation, so we can get the result. But in this case, we can get the racemization product because in SN1 reaction stable carbocation is formed. So this is the sp2 hybridized and a planar compound. So nucleophile can attack from backside and front side, so we can get the racemized product. So from this we can conclude that the reaction is positive from the SN1 reaction. But in some cases, if the tight ion pair is formed, so in these cases small percentage of inversions we can get. So the rate of SN1 reaction also depends on the three factors: the nature of the substrate. If the substrate is the larger bulkier group at the presence of the alpha carbon, that is the most stable carbocation, so this is the more favorable for the SN1 reaction. The ability of the leaving group to leave, this also the important, but it will not participate in the rate determining step. The nature of the solvent, the polar protic solvent is the more important to our SN1 reaction due to the high dielectric constant. So H2 is a very useful solvent to dissociation because there is a heterolytic cleavage also occurs for this reason. So consider the nature of the substrate. So among the 3 degree, 2 degree and 1 and methyl, among them this is the most stable carbocation, then this and this. For this reason we can conclude that this tertiary group also prefer the SN1 reaction than the SN2 reaction. The stability of the carbocation, we all of you know that the first of all the resonance, then the hyperconjugation and the inductive effect. In this case, the 9 alpha hydrogen is there, so for this reason this is stabilized. And these are the conjugated resonance system. This is the 1 degree carbocation, but due to resonance is involved, so it is very much stable. The benzyl, this also the another example. Both are the 1 degree. So 1 degree is or 2 degree is not a matter. The stability of the carbocation is a more predominant factor. The reactivity of the stability. So we are given some increasing order. In this case, the SN1 reaction positive. We can get the very good result. Effect of the nucleophile in the rate of SN1 reaction. So recall again that the nature of the nucleophile has no effect on the rate of the SN1 reaction, because in the rate determinant step nucleophile are not participate. This is the general scheme. So given effect of the solvent, already discussed, effect of the solvent SN1 reaction. So some DMSO, these are not appropriate, so water, methanol, alcohol mixture. So then we comparison between the SN1 and SN2 reaction. So SN1 reaction is a two-step reaction and SN2 reaction is a single-step reaction. In the SN1 reaction, the carbocation is formed, that the intermediate is formed, and the first step is the slowest step, and we can get the racemized product. But in SN2 reaction, no intermediate is formed. Nucleophile attack from the back side, so we can get the inversion of product. The stereochemistry also different from the SN1 and SN2, and polar protic solvent is very useful for our SN1 reaction. But in the SN2 reaction, the polar aprotic solvent, just like THF, DMSO, DMF, these are the very important solvent for us. So overall we discussed about the SN1 and SN2 reaction and their comparison and their stereochemistry. That's all.